So in this video, I want to talk about measurement of length using three units: the meter, the centimeter, and the millimeter. And I want to look at their relative magnitudes. First of all, let me say that here I'm talking about length. I'll combine it with area, and then I'll go to volume. Length, area, and volume are physical quantities. As you very well know, that physics is about the study of physical quantities. That is where physics comes from. In fact, physics and physical quantities are synonymous. A physical quantity must have magnitude. The magnitude of the physical quantity is simply the size of that physical quantity. Some examples of physical quantities that we have could be mass, length, time, volume, force, pressure, temperature, and so forth. These are physical quantities. These physical quantities have units. There's the concept of SI units. Units that have been agreed upon by all scientists in the world. There are 7 basic physical quantities. These include length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. 7 of them. Each one of those basic physical quantities has an SI base unit. For instance, the SI base unit of length is meters. But other lengths could be measured in like centimeters, millimeters, kilometers, nanometers, micrometers, picometers, and so forth. These are multiples and sub-multiples of the meter. Sometimes we quote these multiples and sub-multiples of the meter without necessarily having a knowledge of how big that physical quantity is. That is why I want to talk about the meter. And I'm going to use the instrument or the apparatus which is used to measure length in any physics lab. And this is called the meter rule. The meter rule. The meter rule has got this much size. It's important to appreciate the size of a meter rule so that you're able to make decisions as far as maybe estimation of the magnitude of particular lengths is concerned. If you are to estimate the length of a particular object or a particular dimension, what would you estimate it to? What would you comparing it to? You'll be comparing it with that 1 meter. So it's important to realize how big 1 meter is on a personal basis. It's not enough to be told that 100 centimeters equals to 1 meter. It's not enough. Unless you know how big the meter rule is, you have seen how big it is, then you can appreciate that 100 centimeters make 1 meter. This is what I want to talk about. So, let's start by the fact that we know how big the meter is. It's that big. That is 1 meter. That 1 meter is subdivided into 100 equal divisions. The length of one division is called 1 centimeter. Centi means 100. 100. So, 100 centimeters make 1 meter. What does this mean? That if you get 1 centimeter, you fit them side by side, 100 of them are going to occupy a length equal to 1 meter. And therefore you can say 100 centimeters is the same as 1 meter or is equal to 1 meter. At this particular point, it goes without saying that the meter is larger than the centimeter. 1 meter is larger than 1 centimeter. It's important to get this correct so that you don't make any mistake of saying something like 100 meters equals to 1 centimeter. You know, it can happen unless you've got a mental appreciation of how big a physical quantity is. You can make some of those mistakes. So remember, 100 centimeters make up 1 meter. You arrange 1 centimeter 100 times, you get 1 meter. A simple conclusion here is that the meter, that is 1 meter, is larger than 1 centimeter. As a matter of fact, 100 centimeters fit into 1 meter. The conversion unit you want to recall at this point, after understanding what it means, is that 100 centimeters is equals to 1 meter. Now, if we go to the meter rule and get 1 centimeter, you find that it has been subdivided further into 10 divisions. One of those divisions is referred to as a millimeter. Millimeter. So you can see that 1 millimeter is smaller than 1 centimeter. In fact, 10 of them arranged side by side is what will make 1 centimeter. So in order of increasing magnitude, we can start with 1 millimeter, then we go to 1 centimeter, and then finally we end up with 1 meter. That is, if you arrange 1 meter, 1 centimeter and 1 millimeter in the order of increasing magnitude, starting with the smallest one. The one that has got the smallest size is 1 millimeter. Now, you see, from time to time, we are required to convert from one unit of length into another. I've used these 3 lengths because it is possible to see them with our naked eyes. I've just said that in a meter rule, you can be able to see that big length is 1 meter. You can be able to see another one is 1 centimeter, and 100 of them make that big length, which is 1 centimeter. 1 meter. And then 1 centimeter is further subdivided into other smaller lengths called the millimeter. And we can be able to see this on a meter rule. We do not struggle to see this. It's possible to see these markings on the meter rule. I've started with those because they are the simplest ones and they are the ones that we encounter in the physics lab. All this leads to one conclusion, that in 1 meter, there are 100 centimeters. And in 1 centimeter, there are 10 millimeters. In one sentence, we can say 1 meter is equal to 100 centimeters, which is equal to 1,000 millimeters. And from there, you can get 1 centimeter is equal to 10 millimeters. So now that you understand how big a meter is, if somebody were to take a measurement of, let's say, the diameter of a wire, and reports that the diameter of this wire, which is used in an electric circuit, is 1.5 meters, you will immediately know there is something wrong with that statement. How do you know that there is something wrong? You know how big 1 meter is, and then this person is reporting that the diameter is 1.5 meters. You know that that one is simply not possible. To somebody who does not understand how big 1 meter is, that person will not be able to make this type of conclusion that we are making here. That person will not be able to make that kind of judgment. That person will not be able to argue correctly. In other words, he won't be able to make a proper decision based on the physical quantities, because he doesn't have a knowledge of how big that unit, which we call 1 meter, how big it is. And that is why I say it is important that you familiarize yourself with this simple measuring instrument, which is called the meter rule. The reason why the teacher gives you that meter rule to use is so that with the time you can get to remember, oh, 1 meter is just this big. So if I'm to estimate the diameter of this table, it will be so many meters. And if you read some information in a textbook, you are able to have a mental appreciation, a mental picture of how big or how small that length is. That is the basic, the reason why I'm giving this video, because I've seen situations whereby students give erroneous answers which don't make any meaning at all. And they go ahead and it's not their fault. It's because they may have forgotten about the size of a given physical quantity. So at that point I want to stop, and maybe I'll talk about the length, area, and volume in my next video.